So what the scientists do, the scientists build to understand. The scientists design experiments. They put one electrode here and one electrode here and leave the electron in the middle and see whether it goes to the positive electrode or to a negative electrode, and then derive principles from there. And what the engineer does, he or she utilize that knowledge to build things. So one builds to understand and the other understands to build. This is the difference between an engineer and a scientist. And you should know that. And you can do both. There is no ban. If a person has a master's degree in Pashto and he knows science, it is not a sin. I am called a physicist because I have read a few books of physics. If a Pashto graduate can read more books than me, then he can be a better physicist than me. So never draw hard lines between disciplines. So in the old days, people had nothing but they had clay, khawra. The animals and the human beings used to drink water like animals from the ponds. But it was that clay, the khawra, which they developed into hard pots. And it gave human being the honor, the dignity to not drink like animals. So, he could pick the water from the pond and he could drink it with decency. How did he do it? He did basically engineering of materials. What are you expecting from a pot? You expect three things from a pot. It must be hard enough to sustain its one property, hard enough to sustain its body. Then smooth, shiny, impermeable, so that it doesn't absorb the liquid when you put that liquid in it. Second property, impermeability, hardness. And the third property, chemically resistant. That when you wash it with chemicals, with soap or anything, it doesn't damage with that. And it can be removed from it so it doesn't mix into your food. Three properties, Pakal. What they did, they took clay, they took feldspar, they took quartz. Quartz has a high melting temperature. So when you fire the body at 1200 or 1000 degrees centigrade, the quartz is still there. So it keeps the structure of the body. Then you need the surface to be impermeable. So you put feldspar for it. And feldspar is melting at 950 to 1000 degrees Celsius. And then you need plasticity. And plasticity was given by the clay. So you mixed three materials, clay, feldspar, and quartz in appropriate proportions and fired them in the temperature, and it gave you a pot of clay. How much business? It is $1 trillion business nowadays throughout the world. That you go to the Karkhano market and ask about the products of Rice Dalton, the products of Wedgwoods, bone china and fine china. And they are earning billions of dollars and pounds on that basic thing, and which we couldn't do. You ask the local product price and ask that imported product price. But it was the base of the engineering of material. Then when the electricity came, we used the same materials to make hard porcelain. The transformer cores. When you see in the transformer the white cores, they are basically that material which has been hardened at high temperature. What the people look for now, the people are now playing with atoms. The people are now playing with electrons. In those days, they were doing macroscopic engineering. But nowadays, what is this atom? This is the center of mass and the center of charge are coincided. They are together. The center of mass and the center of charge. And here, the center of charge and the center of mass are not at the same point. What does this mean? This is polarized and this is unpolarized. The whole game of electroceramics runs about this. You are playing with the polarizability of atom, and it has your cell phone. your telecommunication devices, all the modern telecommunication is based on these things. This atom. And if you can't understand it, look at that. Lean the pigeon again. When it is pulled, it has energy in it. When it is unpulled, it has no energy in it. The same thing is here. It is unpulled and this is pulled. And you store energy in the atom via polarization and then utilize it when it depolarizes.